Welcome to the Explainer. Today we're diving into something we're calling Beyond Decoration, and we are absolutely unleashing the true power of CSS. But before we get into the crazy new stuff, we have to start with a universal, deeply shared grievance among developers. We all know the exact moment. You're building a layout, you just want to center a simple box on the screen, and somehow, 45 minutes later, you are aggressively fighting the browser, you're refreshing the page like a maniac, and you're genuinely questioning your career choices just to get a single layout right.
Oh man, it is the ultimate developer rite of passage. But it actually perfectly sets up what we're arguing today. CSS is a serious, highly optimized engineering tool that almost everyone drastically underestimates.
I mean, there is a reason how to center a div has been Googled more times than how to cook rice. And honestly, cooking rice is harder. It's funny because it's so true. But here is the real problem with that joke. This exact struggle makes developers falsely conclude that CSS just isn't a real language. Exactly. They get super frustrated, they walk away thinking CSS is fundamentally broken, and it drives them straight into the arms of JavaScript for absolutely everything. They think, well, if CSS can't even center a box intuitively, I am certainly not going to trust it with my application's actual UI logic. Okay, let's dive into the hard technical truth here. Reaching for JavaScript to handle your UI logic and your animations is, in most cases, mathematically inferior to using the native rendering engine. Just think about the comparison for a second. JavaScript-driven animations run on the main thread.
Right, and the main thread is so easily blocked. Like, if your user clicks a button and your app has to fetch a bunch of data or run some heavy client-side calculations, your JavaScript is busy. So what happens to your cool JS animation? It stutters. It drops frames. It looks completely terrible.
Exactly. But on the other side of the equation, CSS animations run directly on the GPU. They operate completely independently of the main thread. So even when your JavaScript is completely bogged down and struggling, your CSS animations just keep going perfectly smoothly. They are essentially free. Now, what's really fascinating is how beautifully simple the native alternative actually is. Take that trendy, organically morphing blob shape. You know the one? You see it on literally every single modern developer portfolio or startup landing page right now. Oh yeah, that smooth, wobbly thing. I honestly always assumed that was some complex canvas rendering or heavy SVG math going on behind the scenes. Nope. It is literally just 4 lines of CSS and an animation keyframe. It's just manipulating the border radius percentages over time. Wait, hang on. It can just do that natively? You're just interpolating border radius values to make it look like liquid? Natively. CSS has a completely full-featured animation engine built right into it. Delays, timing functions, iteration counts, the whole shebang is just sitting right there. Which makes this next part literally hurt my soul. The absolute madness of modern web development is that people are out here installing massive NPM packages just for a blob.
They really are. They pull in GSAP, they set up a whole HTML5 canvas context, they're manually writing request animation loops.
It's crazy. You're literally downloading a dependency tree the size of a small black hole, and you're shipping all that heavy JavaScript baggage to your user's phone just so a shape can wobble on the screen. It is completely absurd when you contrast it with 4 lines of native CSS. It really is. So let's see how this builds into even bigger architectural features. Think about how long a smooth page transition actually takes to build.
Oh man, the old painful way?
So say you want a thumbnail card on a grid to smoothly expand and morph into the giant hero image on the detail page when the user clicks it.
Right. Historically, that meant building an entire single-page application, pulling in a heavy React transition library.
Oh yeah, and managing incredibly complex routing state.
Or, even worse, relying on some half-working Stack Overflow answer from 2019 that completely broke the browser's back button.
That was easily a whole weekend project. Just guaranteed agony. Well, with the new Vue Transitions API, that agonizing weekend project is now exactly this many lines of code. 2.
Wait, actually? Just 2 lines?
Literally 2 lines of CSS. You give the element on the first page a Vue transition name, and you give the corresponding element on the second page the exact same name. That's it. The browser completely takes over. It snapshots the before state, snapshots the after state, and automatically animates the morphing between them when you navigate. Absolutely no JavaScript required. Developers are plugging this in and literally sitting back saying, wait, that actually worked? It's pure magic. And speaking of magic, if we look at heavier architectural features, we have to talk about the has selector. This is a parent selector. It allows you to style an element, like a section or a card, conditionally, strictly based on what is inside it.
This is huge. So the crucial point here is that if you want a container to have, say, a red border only if it contains an error message inside it somewhere, you no longer need to write JavaScript to check the DOM, detect the error, and toggle an error state class on the parent. The CSS just watches the DOM and reacts completely on its own.
Because CSS can genuinely do logic now, we finally have things like container queries. Your UI component can reflow and change its layout based on how much physical space it actually has inside its parent container, regardless of the overall screen size. This is incredible because developers begged for container queries for 25 years. We were stuck with media queries that only knew the size of the whole viewport, which made building reusable components an absolute nightmare. And now it's just native. Plus, look at the property rule. You can finally define the specific type of a CSS variable. You can tell the browser, hey, this custom variable is specifically a color, and because the browser knows it's a color, it can natively animate and interpolate it. Which leads us perfectly to my absolute favorite piece of developer pain: building scroll-driven animations or parallax effects the old way. This is just shared trauma.
Ugh, I have lived this exact nightmare so many times. Okay, first you set up an intersection observer. Then you attach a scroll event listener. Step 3, math. You are running constant JavaScript math on the main thread, calculating offset tops, subtracting window inner heights, dividing by scroll deltas.
Which inevitably leads to step 4, a bug you cannot reproduce where it works totally fine on your desktop but violently shakes on mobile Safari. And finally, step 5, leaving a warning comment in the code that just says, do not touch this. You end up with 3 files of absolute garbage just to make a simple reading progress bar. And here is the beautiful punchline to all of that. All those files, all those impossible bugs, all those complex math equations, completely replaced by native browser behavior.
Literally one line of CSS. Animation timeline, scroll. That is it. It directly and perfectly ties your animation's progress to the user's scroll position. You want a progress bar at the top of an article? One CSS property. Elements fading in elegantly as they enter the viewport? One property. You just delete 3 files of JavaScript and let the browser do its job.
But look, we have to be fair here and acknowledge why people ran away from CSS in the first place. It comes down to styles bleeding across components at 2 a.m. right before a deadline. The absolute soul-crushing PTSD of specificity wars. Oh man, the 2 a.m. panic. You change the color of a button in the footer, and somehow, for some reason, the entire navigation bar collapses. One class overriding another in ways no human could logically explain. This guessing game is literally the only reason CSS and JS hacks ever became popular. Writing our visual styles as JavaScript objects and injecting them at runtime always felt fundamentally wrong, but we did it anyway, because the alternative was losing our minds. But we survived the dark ages. Today, we have cascade layers with the layer rule, and we have CSS modules. These tools explicitly define the exact order that styles apply, and they automatically scope your styles to specific components.
Exactly. You write a generic class like card, and the system automatically compiles it to a unique hashed string. No more bleed, no more conflicts. You declare what wins before the rules even run. The cascade finally became something you can actually predictably control.
I mean, sure, I'm a little annoyed it only took 30 years to get here, but hey, we finally made it. So let's talk about what senior engineering roles actually look for today when it comes to the front end. Knowing how to use Flexbox or CSS Grid, that is just the floor. That is basically expected day one.
The ceiling is knowing how to ship buttery smooth 60 frames per second GPU optimizations without burning through your JavaScript budget. It is knowing exactly why a CSS transition is cheaper than a JS one. And critically, knowing when you are misusing performance properties like will change. Because if you just slap will change on everything hoping it goes faster, you will completely tank your user's device memory.
Exactly. True senior knowledge doesn't come from just knowing how to center a div. It comes from going way past the part where most people stopped learning. And that brings us to the core argument of this entire explainer. CSS is the only language in the stack that runs directly on the browser's rendering engine. Period. Everything else, your React frameworks, your utility libraries, your heavy JavaScript bundles, it all just sits on top of it or tries to clumsily work around it. When you don't know CSS well, you end up paying JavaScript to do CSS's job. And your user is the one who ultimately pays the price in massive loading times, janky animations, and sluggish heavy pages. Which leaves us with this final, provocative thought. Take a hard look at your codebase. Are you still paying JavaScript to do CSS's job, or are you ready to finally learn the language you thought you knew? The ceiling on CSS is so much higher than most developers ever bothered to check. It is absolutely time to stop fighting the browser, drop the heavy dependencies, and let the native engine do the heavy lifting for you. Thanks for joining us on this explainer. Challenge yourself to raise your ceiling, and we will catch you next time.